So we're going to take a look at another advanced mechanics question. We're told draw a graph of the trajectory of an object launched at velocity v at an angle theta. We have to include the following vectors. So we have to include vectors directly after the launch, when it's at the maximum height, and prior to landing. So when it says include vectors, we're assuming this means horizontal velocity vector and vertical velocity vector. So we're going to start by drawing our graph. We will launch the object from the origin. So the object will launch here. It will follow a parabolic trajectory, pretty much like so. That's not a bad graph. So this is the y-axis, this is the x-axis, this is the angle theta, and then this vector will have magnitude v. So it asks us directly after the launch at the maximum height and prior to landing for the vectors in x and the vectors in y. So I'm going to change color here. So just as it launches, let's pick a point just after it launches here. It has a horizontal component this way and it has a vertical component up this way. And we can see that combining these two vectors would give us a vector approximately similar to the launch vector. Right, so we know that that's roughly correct. So that is directly after the launch. At the max height, well at the max height that's up here, it now has no velocity in the y direction. It only has velocity in the x direction. It's just sort of hovering in the y direction. It stopped and then it will turn around. So this is part 2, this is part 1. And then they say prior to landing. So we'll pick this point down here. This is the point just prior to landing. It's still moving the same velocity in the x direction. Notice the x vector is the same in all of these. The x vector stays the same all the time in this kind of trajectory. But now the y vector is pointing downwards. So the only vector that changed was the y vector. It went from positive as the thing was going up, 0 when the thing was at its maximum, negative when the thing was coming back down. So this is the answer that the question wants. This is what it looks like when you draw a trajectory graph and you add the velocity component vectors in x and in y.